Now we're going to look at all the parts and pieces that make up a motor control circuit that you would draw in a ladder diagram. First of all, as we mentioned before, power comes in, the line voltage comes in at 480 volts, three-phase, and that is what the motor runs on. But the control circuit is single-phase, 120 volts, and so what do you have to do to get down to 120 volts? You need a step-down transformer. And this is actually the answer to one of our questions in the worksheet. I just want to note that this is kind of an old drawing, and the way you can tell is it says 440 volts coming in and control voltage 110 volt. Power generation and transmission has gotten more efficient over the years. It used to be that it was 440, the stove in your house was 220, and your wall was 110. Then things got a little bit more efficient, and it went up to 460 in the line, 230 in the stove, and 117 in the wall. Nowadays, I should fix this, because nowadays we are at 480 volts in the line in a three-phase power, 240 volts in a kitchen stove, and 120 volts in a wall outlet. Just FYI. Motor control circuit has three basic components, which you couldn't tell by looking at this whole ladder diagram thing here. It looks like a lot more than three, but we're going to break these down. Starting with a disconnect switch, they look like this, and you can see how the switch has all three lines that get opened or closed together, and there are fuses in there also. Then there's a starter, and the starter includes the controller with contactors and overload protection. Eaton Corporation likes to call this the starter equation. So in the starter equation, starter equals controller plus overload protection. Part of that controller and contactor is a set of contacts in the contactor, and note that when the contactor is for the motor starter, there's an M in its name. So when you're reading these ladder diagrams, look for that M, and that means that's the contactor that is the motor starter. And I think there's a question about that in our worksheet. The starter actually has two different circuits, a three-phase 480 volt power circuit and a single-phase 120 volt control circuit. And they're both shown in the ladder diagram as you see here. The control circuit operates a set of contacts which pull in another set of contacts for the motor starter. The contactor, it looks like this, and it has contacts and it has a control relay. And what's interesting about that is that the control relay switches small currents, few amps, and those are like, I don't know what they're like. They provide enough current that they can then pull in these big contacts which switch big currents. The relay, the control relay, is a communicator, and when you look on a ladder diagram and you see CR, that stands for control relay. And you'll notice these control relay contacts are over here on the 120 volt side. They are switching small amounts of current. They are the ones that talk to the bigger motor starter contacts. So CR is control relay. Here's the contactor. The contactor also, it has a big contactor, and it also has some auxiliary contacts, which we're going to look at in the diagram. Then there's overload protection, which you need, and it's required by code. And if you look at the diagram, you see here is the three-phase 480 volt side of the house with the actual motor itself. And these squiggly things are called heaters. They're heating elements that are part of the overload. Then these things with the two vertical lines representing contacts, with the diagonal line through them, meaning normally closed, these are the contacts for the overload relay. So these two are part of the same device. Here's a picture of a kind of an old-timey picture of an overload relay. Now the control station, in other words, the on-off switch. So we looked at some pictures of some push-button stations, and here's what they look like in the diagram. This is a symbol for a push-button start button, and this thing here is a symbol for a push-button stop button. And you will notice when you study it that the stop button has contacts that have made contact with the rest of the circuit here, so current can flow through that stop switch. It's not stopping anything. However, the start button is floating up in the air here. It has not made contact with these two contacts, so until you push down this start button, no current can flow through here. This is an example of a normally open switch. Here's what push buttons can look like, and they are often accompanied by indicator lights that show the state of the situation. So if the thing is on, the green light will light up. And by the way, these push buttons are spring-loaded. So when you take your hand off the button, it returns to whatever its normal position was. And here are some examples of different kinds of switches, but honestly, we're usually talking about push buttons. Okay, now, in most ladder diagrams, you see a thing that looks like this with two lines in parallel. And here is the normally open push button start switch. And remember we said that's spring-loaded, so when you take your hand off this, it pops back up again. But here's the way it works. You put your hand on the push button and push it down, and it makes contact. And that contact causes current to flow through this circuit, and not only does it flow through the start button, it also flows through this auxiliary line where there are two. Do you know what those are? You already know CR stands for control relay, and you probably know those two little lines are contacts. So when you push this push button switch, it makes momentary contact long enough to make those control relay contacts close, and they stay closed. And now when you take your hand off the button, it pops up, but that's okay because these contacts have pulled closed and current is now flowing through this holding circuit, through these contact relays, over to start the motor. And speaking of starting the motor, so here's that circuit again, and it's interesting to note that there are control relay contacts shown in 3 different places on this diagram, and they're all part of the same circuit, and they're all actually wired together. So these CRs are control relays and control relay contacts that pull in the control relay coil. That's the low current one we looked at. It's small and lightweight, but once it gets pulled in, it pulls in the contacts for the big one, the motor coil, and now the motor can start. And so here is the 1M, the motor starter coil. And here, now over here in the 480 volt lines, next to the motor itself, are the contacts in the actual motor starter. So the control relay, the push button closes the control contacts. They make the motor big contacts close, and they make the motor run. And you let go of the push button and things keep running. Then if you want to stop the motor, you push down on the stop push button, and that breaks the circuit. It opens the circuit. Now nothing is making contact, current can't flow through, and the thing stops. When we talk about these big three-phase motors, there are several methods of starting a motor, and I'll just talk about the first one and the last one. Across the line start means you just start and the thing goes from dead stop to full-on running with there's no on-ramp. It just goes from off to on. That works okay with small motors, but you may be aware that when a motor starts, it draws a lot more amps than it will when it's running. There's a high starting amps. So with a big motor, this can be a problem. It can draw way too many amps. And so with a big motor, what they do is a thing called part wound motors, or part winding start. And that's what this ladder diagram is showing. And we won't talk about that right now. But what it's showing is that when you push the first start button, it pulls in some auxiliary contacts for what are called the start windings. It's only part of the motor that starts spinning around and around. And as it gets up to speed and things get going, then those start windings and their contactors pull in the run windings. And now the rest of the motor is running, and now the whole motor is running. So that's a lower impact way to start a motor that's a big horsepower motor. So there's a whirlwind tour of a motor control circuit. Next time we're going to look at how to draw ladder diagrams that represent these circuits.